Hello, my name is Leanne, and we will go over data visualization this time. So first, what is data visualization? So data visualization is a graphical representation of data to convey information. And this is an important skill to master in a field of data science and also in any discipline. And why is good data visualization important? We say a picture is worth 1,000 words. So it means that it's easier and quicker to absorb information with pictures. And especially in the age of big data, data visualization is essential to analyze large amounts of data and to make data-driven decisions. And we can look over what type of data we can have. So think about the data type you want to visualize. First, it could be quantitative, so it means either continuous or discrete, or it could also be qualitative, ordered or unordered, and data could be time series and text. So it is important to ask what type of graphs you want to portray to best visualize those data. And next thing is to think about the audience. You're telling a story with your data, so why the story matters to your audience is important. So you have to also consider if the audience has a strong technical background or not. And then we should consider colors as well. Colors make it easy to categorize data, but not everyone sees colors the same way. So it is recommended to use colorblind friendly palettes for accessibility. Also, color choice has an impact on data. So for example, if you have a temperature data, you want to use red for higher temperature and blue for lower temperature. And what is good about R is that R has some colorblind friendly packages you can use, so you can choose those colors really easily. And before we go into a demo, there are 5 tips for improving data visualization. So first, show the data, then reduce the clutter, and then integrate the graphics and text. And also avoid the spaghetti chart and graph having too much information because this could be too complex. The last tip is to start with gray. And then I will introduce ggplot in R. ggplot means grammar of graphics, and it lets you plot graphs by combining independent components. So your plots are going to build up layer by layer. All plots have 2 major components. First, data you want to plot, and then mapping of your data variables to attributes. Then we will create the first ggplot. Let's load in the required packages before we move into the practicum. We use this tidyverse package, which is an R library, to make ggplot. So first, we have to library in this tidyverse package. Then in this demo, we are using the penguins dataset from the previous EDA section. So we have to load in this Palmer penguins package. So in line 1, we have this Palmer penguins package loaded in. And first, we will visually explore our dataset to see our data distribution before we start telling the story. So by using this glimpse function, we are going to look at the rows and columns of this data set. So for this data set, we have 8 columns and 344 rows. The columns include species, island, bill length, bill depth, flipper length, body mass, sex, and year. Then let's create the first ggplot. Think of ggplot as a blank canvas first. And then you set up this blank canvas before you start painting the picture. So in line 6, we have ggplot and data equals penguins. So this is going to create a blank canvas. So it's not showing anything right now. And in order to add data points into this blank canvas, we need aesthetics. Aesthetics describe every aspect of a graphical element. And think of aesthetics as attributes to the drawings you're painting on your canvas. So those aesthetics could be shape, size, color, line width, line type. Then let's first start from gray and show the data that we have. Let's explore the island column first. So in this code, we have ggplot data equals penguins, which makes a blank canvas. And this geobar is a geometry or a type of plot you want to generate. Here, it's a bar graph. So you are going to create the bar graph. And here, aesthetics is in AES, X equals island. So this means islands are going to be in the X axis. And here, stat equals count means the number of penguins in each island would be in the y-axis. Now that we have pretty good insight on what our data set looks like, let's move on to figuring out what information or stories we can tell our audience. Some questions we can explore together are, first, what is the correlation between the bill length and depth? Second, what is the difference between male and female bill length and depth? And lastly, how does the island affect the bill length and depth of penguins? Our next step is to reduce the clutter in our plots in order to start shaping a story to tell our audience. So first is to visualize the bill length and depth of penguins. In this code, we have ggplot as a blank canvas, and we have geom point as a geometry or type of plot you want to generate. And here it's a scatter graph. And aesthetics would be x equals bill length, which would be on the x-axis, and y equals bill depth, which is the y-axis, and color equals species. And this labs would be changing labels. So if you look at the output, this code, an aesthetic called color, we have 3 species in 3 different colors. So we can see 3 groups in each color. And then we can visualize the difference between male and female bill lengths and depth. So here we have the same code, but we added another aesthetic called shape. So it has an argument called shape equals sex. So what this shape equals sex does is having another category called sex and differentiating female and male by the shape of the points. So here, female is represented by like circle shape, and male is in triangles. And lastly, we can visualize the penguin's bill length and depth in different islands. So here we have the same code, but I added the last line called facet grid island. So what this facet grid does is making additional graphs in 3 different. So what this facet grid does is plotting 3 different graphs at the same time. So if you look at the output, we have the same x-axis and y-axis and 2 different shapes by sex, but we have 3 different graphs by island. And then next thing we can do is to make graphs more presentable. To make our plots more presentable, we can add more features such as themes, colors, axis labels and scaling, and some annotations. So there are some pre-made themes in ggplot. For example, it is theme BW, which means black and white. And we can also customize some theme elements by using this theme function. And if you want to choose a color palette of your own choice, you can use this scale color brewer function with the same aesthetic, but we used this pre-made theme in ggplot called theme BW, and I customized some elements by using this theme function, and I used a palette called 13 to change the colors of the data points. And another cool thing about ggplot is that you can also create your own theme and color palette. So you can use it for internal use or brand recognition. So here I created a new theme by customizing some theme elements. So I was able to change some legend title, legend text, axis title, plot subtitle, and some plot captions. And all of them, they're all up to you. So you can change the font size, font type, and like the face, and like the size of the text. This MPG dataset contains a subset of the fuel economy data. So it has a bunch of information about cars. So if you look at this dataset, there are 11 columns. Here we use geom histogram to plot the bar graph. So first we have a blank canvas called ggplot, and we have a geometry called geom histogram, and aesthetics are x equals class, y equals n, and field equals class. And stat would be identity. N is the number of cars in each class type, and stat equals identity specifies the ggplot to plot the number of count for class. And also I used a new theme that I created to plot this. And this is the output. So here we have class and count. So we have the data distribution by car class type. And also in R, we can plot pie charts. But pie charts are best avoided because it doesn't tell much information about each part. And humans' visual perception on angles are weak, and we cannot tell apart 15% versus 14%, and like 18% versus 20%. So even though we can create pie charts, it's not recommended. And also, you can show even more detail for data distribution by using box plots, violin plots, and data points. Here we do that using geom box plot, geom violin, and geom jitter. So we have geom violin, geom box plot, and geom jitter in this code. Some key takeaways from this presentation are: first, think about the audience and what's the story you want to tell. And then think about your data type and type of visualization you want to create. What kind of graph suits your audience? What kind of graph fits your data best? And then follow the 5 guidelines for data visualization. And lastly, be mindful of visual perception and color choices. And we have a glossary of this presentation. ggplot is grammar of graphics. Data visualization is a graphical representation of data to convey information. Dataset is a collection of data used for a visualization. And lastly, variable is any measure in the dataset. And then there are further resources that are available, and I recommend going to the first link to see the collection of charts that could be made with the R programming language. So there is a distribution chart, correlation chart, ranking chart, part of the whole chart, evolution, math flow, and like knowledge plot. So you can go over the plot of your interest, and they also provide the codes here, so you can try making a chart. Thank you.